going to be utilized in order to detect or in order to quantify the analyte present in any sample. So instrumental methods are very important. So when you compare the advantages of instrumental techniques with the classical techniques, some classical techniques are highly superior when compared to instrumental techniques, because instrumental techniques are going to be not usable for some type of analysis. Say for example, in a gravimetric method, you will be utilizing a chemical reaction in which the chemical reaction is going to produce you an insoluble residue, insoluble product. If there is no any suitable technique, instrumental technique is available to detect the insoluble residue, insoluble product, then the classical technique is going to be the most suitable one. So irrespective of its sensitivity, the classical technique is going to be the most suitable one. So it is highly selective. So we cannot say all classical techniques are non-selective. They are not selective for the determination of the analyte, but not only the selectivity, sometimes we may also consider the sensitivity of the analytical methods. We cannot compare the sensitivity of the classical methods with the instrumental methods, because some instrumental methods we will go down even 10 power minus 14 molar concentration of analytes may be able to be detected. If you take molecular fluorescence spectroscopy, 10 power minus 14 molar, this is going to be the amount of the solute we are able to detect in molecular fluorescence spectroscopy. But if you consider gravimetry or titrimetry, per trial, in order to complete a single trial, at least we may need 5 to 10 milligram of the sample. So classical techniques are less sensitive than the instrumental techniques, but even though they are less sensitive, sometimes we cannot withstand, we cannot withdraw the applicability of the classical techniques, and we cannot replace them with the instrumental techniques. With certain combinations of elements or compounds, the instrumental method will become more selective sometimes. Sometimes if you compare the performance characteristic of the instrumental technique with gravimetric or volumetric approach, the instrumental technique may become more prone to interference, but gravimetric or volumetric techniques, they are free from interferences. Therefore, the superiority we cannot quote. We cannot say instrumental techniques are superior. Even we cannot say the classical techniques are superior. But on the other direction, with respect to the accuracy, convenience, or expenditure of time, it is very difficult to distinguish classical techniques from instrumental techniques with respect to advantages. Not only the characteristics, because say for example, an instrumentation is required and it may be costing about 50 lakhs or 1 crore rupees. In order to establish an instrumentation technology in your laboratory, you may have to invest 50 lakhs to 1 crore rupees. Say for example, if you have better knowledge about titrimetric principles or principles of titration reactions, at least you can have a sample size of 5 milligrams to 10 milligrams and you can complete the analysis with the need of just a burette, pipette, conical flask, etc. So you need not to have a detector of costing about 25 lakhs, you need not to have an instrument of cost 50 lakhs to 1 crore. So cost is very high for instruments. In the meantime, even all general chemists, as analytical chemist, I can say that I can handle all the instruments because I am well experienced. Suppose you all are my students, and if I allow any one of you to handle the instrument, NMR spectrometer, or the LCMS or IPCMS instrument which is available in your laboratory, will you be capable enough to handle those instruments? No, because you are not expert enough. You are not a skillful operator. So in order to make you to become a skillful operator, or in order to make you as an expert, you have to be given an adequate training. So while using instrumental technique, not only the instrument will be costing more money, it is less economical, it is not cost effective. It needs highly skillful operator with respect to personnel to handle the instrument. And even for titrimetric and gravimetric analysis, we need not to have more knowledge in the interpretation of the results, but While
We can
handling the
obtain better
sophisticated
results while
instrument,
using
we must
instrumental
have the
methods.
knowledge in order to interpret the results.
When you
We must
compare the
have the
results
knowledge to
obtained from
convey
the
the results
classical
online
methods
to a person who
and
is sitting
instrumental
in
methods,
UK or Saudi Arabia,
the
wherever.
amount of the sample
So
required to
therefore,
complete the
instrumental
analysis for
techniques,
classical method will be more.
their advantage, yes,
And as
at
the
one
sample
point
size
of
is
view. In the
increased,
meantime, there are
as the
also
sample size is increased,
disadvantages.
the
So
relative error it
irrespective
may
of
be
the
or the
properties
relative
of the
handling
analyte,
emission it may
we can
be, they are
propose
also
many
obviously
instrumental
going to be
techniques,
increased.
and we can
Means the
propose
accuracy
many
and
analytical
precision of the
procedures
results
by
are going to
using
be
different
great.
instrumental techniques for
But in
the
instrumental
analytical
methods, we
purpose.
can reduce the
So
sample size
while
at
using
least by a
instrument,
factor
one should
100 or 1000
understand the
times.
definition of
So by
an
reducing
instrument.
the sample
What
size,
is an
even we
instrument?
can reduce the cost
So the instrument, let me
without
derive the
compromising with the
analytical
results.
instrument. What is the
And some
definition of
miniaturizations
analytical
we can do
instrument?
while
It is a
following the
communication
instrumental
device.
methods.
What do you
And
do
these
while using
miniaturizations
analytical
are
instrument?
maybe in the
You
preparation
will
of the
just introduce
sample,
a sample either to the
elimination
sample
of
holder
the
or to
manual
the any
extraction
compartment of
steps,
the instrument.
usage of the
At the
larger
end, you will
volumes
be
of the
ending up
organic
with a
solvent,
graph or the
and the
result,
generation
whatever
of
it is.
larger
You
amounts
assume
of the
according
waste
to your
due to the chemical
convenience.
reaction.
So
So
it is a
all these
communication device.
miniaturizations will
It
be
will
done. We can
convert the
increase at least
amount at the
100
type of the
samples at a
sample,
time,
whatever
so
introduced
that
into it,
all those 100
into the
samples
signal.
can be
Means that signal
analyzed
with respect to
within
either
10 minutes or
characteristic
5 minutes or
features or
30 minutes.
quantitative aspect of this
So auto
analyte present
samplers
in the
can be
sample.
hyphenated with the
So,
instrument
if
what
you
we are
assume
going to
me as
choose
an
for the
investigator,
analysis. So
I
this is
need
called as
some
miniaturization.
information about the sample or about the analyte
Right
present
from
in
the
the
introduction
sample.
of the sample to
This
the
device
analytical
is capable
system or
enough
the
to convert the
instrument,
analyte or the
up to the point
analyte
of
present in the
generation of the
sample
result,
into
everything will
a
be done by the
communicable
instrument. This is the
form.
main advantage
Into a
of the
communicable
instrumental
form
methods.
means the
Therefore,
electrical property of the
miniaturizations
compound
can
is
be
this one. This
employed
much
by
amount of the
using
current has been
instrumental methods.
generated, and this is the
It is
weight of
very
the
easy to
product
handle the
obtained
data.
at the
What we
temperature
obtain at the
200
end of
degrees
the
Celsius,
analysis, the
etc.
data, we can
So it is a
convert
communication
the
device.
obtained
It has the
data into our
capability to convert
compatibility. So it is very
the
easy to
sample.
process
It
the
may be
data
in
while
solid
using the
state or liquid
instruments,
state or in
because
gaseous state,
the
whatever
data
it
will
is.
be a
It has
computer
the
generated one
capability
with respect
to
to the
give the
sample
signal,
what we are
to give
using,
the output with
and with
respect
respect to the
to
data
the
given by
characteristic
the
feature
reader
of the
device,
solute present in
the
the
computer
sample. So
programming can be
investigator
made in order to
can
convert the
retrieve
obtained
the
data
data,
into any
can
other form.
retrieve the results with
Therefore,
respect to the
the ease of
analyte,
data processing
and
is
for
seen
his
in the
convenience,
instrumental
he
methods.
can use those
And it is
results
very
in
easy
order
to
to
convey the
interpret.
results. Suppose
So,
I am analyzing a
what this
sample in
instrument
Mysore.
will be having
If I
primarily,
am
this
willing to
instrument should
convey
have
the results
primarily
of
a
my analysis
stimulus.
for a person
A
who is sitting in
stimulus.
Dubai or USA or in
Stimulus is very
London,
simple to
wherever,
define,
I
which is
can simply
usually in the
make
form of
analysis online,
electromagnetic or
and
electrical or
parallelly the
mechanical or
fellow
nuclear
can be
energy.
able to know the
Suppose
results of
you
my
take a sample
analysis
holder and you
while
fill the
sitting in
sample holder
London
by means of
or
a
Dubai or
solution
any other
which has been
places of
prepared by
globe.
dissolving the given sample in a
And
suitable solvent.
another important advantage
So
of
through the
these
sample
instrumental
holder,
techniques is
you will pass a
suitability and
beam of light
simplicity.
radiation.
To apply any
After passing
analytical
a beam
method
of
for
the light
analysis of real
radiation,
samples.
if the
So
analyte
because
present
of
in the
these
sample
parameters,
is
the
having the
instrumental methods
capability to
are
absorb the light
quite
radiation of particular
advantageous
wavelength,
when
it will
compared to
absorb.
other analytical
If the
methods.
analyte present in the
So
sample is
normally,
having the
the analytical
capability
methods
to
can be
emit the light
classified
radiation
into
of
classical
different
methods
wavelength
and
than the
instrumental
incident
methods.
beam, then
Classical
the amount
methods
of the
are
light
very simple to
absorbed or the
define.
amount of the light
We may
emitted is
use
going to be
precipitation
measured by means of a detector.
reactions, extraction
With
process or
respect to amount
distillation
of the light
process.
absorbed or with respect to
All
amount of the
these
light emitted,
techniques
and which
are
could be
employed
possibly
only for the
measured by means
separation
of the
of the
detector,
analytes present in the
we will
sample.
be in a position
A
to
sample may
say
be
what is the
a
amount of
binary
the
mixture,
analyte present
ternary
in the
mixture,
sample.
quaternary mixture, whatever
So,
it
in
is.
order to do this, a
We can
stimulus
be
is
aiming
required.
for the separation
Stimulus
of
is a
individual
medium.
analytes
Stimulus
present
is a
in that
medium
particular sample,
in order
which
to
is a complex
initiate the
mixture.
interaction between
So
the
this could
analyte
be
present
done
in the
either by
sample
precipitation
and
process or
either
extraction
electromagnetic
process or
radiation or
distillation process. Another
electrical
qualitative
source or
analysis can
mechanical
also be
source or
done
nuclear
by
energy,
making
whatever it
two
is. This is
analytes to
called a
react
stimulus.
together
So
to form a colored
here I
product
can show a
or the
picture
product which
in
may
order
be
to obtain the
distinguishable
role
from the
of an
starting
instrument.
materials
A
what we can use,
stimulus, you
and which will
assume
be
a
having the
source of
different boiling or
bulb is
melting points when
glowing,
compared to
is
the reactants,
illuminating in
and
order
which
to
also may
produce
be having the different
a
solubility
beam
when
of light
compared to the
radiation
reactants.
or
Not
multiple
only these
beams of
parameters
light
but also
radiation,
optical activities
and that beam
and
can be
refractive
converted into
indices
monochromatic beam by means of a
Even
filter.
quantitative analysis
By
can
means
also
of
be
a
done
filter, we can
by
convert this
performing gravimetrie
polychromatic
or
beam into
titrimetric
monochromatic
analysis.
beam, and this
In
monochromatic
gravimetrie,
beam can be made to
mixing up of
incident
two
on the sample
reagents
which
to
is
form a
present in the
precipitate,
sample holder,
and weight of the
and that can
precipitate
be
will be
considered as a
recorded.
system under
With respect
study.
to the weight of the product
So,
obtained, we are
stimulus
going to
will become responsible to provide either electromagnetic or electrical or mechanical nuclear energy source, and this stimulus provided the energy, and that energy is going to interact with the solute which is present in the system under study, and the transformation of the analyte present in this system under study is going to be taken place, and the detector will become responsible to give the response, and that can be utilized as analytical information.
classical techniques.
So this is how the stimulus is going to be important. So stimulus elicits a response from the system under study. This is going to be the system under study, and this stimulus, it may be in the form of electromagnetic radiation or electrical energy or mechanical energy or nuclear energy, whatever it is.
Are nothing but
This elicits a signal from the system under study to the detector, and this detector will convert the signal into appropriate light. Dependent upon the conversion or the output given by the output device or the readout device, we will be in a position to obtain what is the amount of the solute present or what type of the solute present, and here the response given by the instrument will obey the fundamental laws of physics or chemistry, because either physical property or chemical property of the solute is going to be utilized here during the interaction of either electromagnetic radiation or electrical property, electrical energy or mechanical energy or some other type of energy which is going to interact with the system under study in order to convert the interaction between the stimulus or eliciting of the stimulus and the system under study into a response. So this is how the instrument can be defined. So in an instrument, the stimulus will become responsible to elicit a response from the system under study which is having the analyte into a response, and this response is going to derive an analytical information.
This is going to be the game
So
of
let us
any
assume a
instrumental
simple
technique.
spectrophotometric
So
analysis. So what we will be doing in
category
our
based on
analytical
its role,
laboratories or chemistry
rules
laboratories
of the instrument.
where we
Any
will
instrument
be
is
using
going
a
to
source
play a
of
role
light
either
energy,
for the detection
and
of
this
the
source
analyte
of light energy is
by
going to
fetching
provide
with respect
you a
to the
polychromatic
chemical or
beam,
physical property of
and
the
by
analyte
means of
present in the
appropriate
sample.
filter you
And
are
the
able to
second one,
convert that
by
polychromatic
utilizing
beam into a
the amount of
monochromatic
the
beam,
analyte present in the
and this
sample,
monochromatic beam will be having a
give you the
typical
signal
wavelength,
output
a
signal
fixed wavelength,
based
and
on
that
the
is
output
made
signal
to
or
fall
the quantum of the
through
output
the sample
signal what we
solution
have
which is
obtained.
present in the
We
cuveator,
will be
which
in
is
a
present in
position
the sample
to
holder.
say what is the amount
So
of the analyte present in the
some
sample.
amount of this monochromatic
methods
light
can be
energy
classified
has been
into,
absorbed by the
different
species present
types
in the sample
depending
holder, and
upon
the
the
remainder is
characteristic
going to fetch the
properties
detector,
of the
and the
analyte.
detector will be responding in such a way
So,
that the analytical
the radiation
information
may be
about the
emitted
analyte
from the
present in
analyte,
this sample holder
light
can be
radiation may
obtained
be
very
absorbed
easily.
from the analyte.
So this is going to be the stimulus
scattered
here.
from the analyte.
This is the system
The
under
radiation
study,
may
and
be
this is the
refracted
analytical
from the analyte
information.
or diffracted
So
from the
stimulus
analyte, and
will
the light
elicit a
radiation may be
response
rotated by the analyte.
due to
So,
the
these
interaction
are all
between
the
the
properties of the
monochromatic
analyte.
beam and
Why
the
the
solute
radiation
present
is
in
emitted
system
by the
under study.
analyte? Because
So elicit a
majorly
response
due to the
definitely.
conjugation
So
and structural arrangement
polychromatic
of
beam
that
has been
particular
converted into monochromatic
soon
beam.
after
Here no interaction
interaction
taking
of
place
a light
between the
radiation with
polychromatic
the
beam
analyte,
and the solute.
a typical
The
light
interaction
radiation
is
is going to
taking
be
place
emitted
between
out from the
monochromatic
analyte,
beam and the
and
solute.
that may be due to
So
majorly
you can see here
excitation of
the analytical
the molecule
information
to the
has been
higher
obtained
energy
by the
level,
detector.
where
So
it
this
will
is
reside for a particular interval of
response,
time, and it will come back to
system
the
under
ground
study,
state
and
with
this
the
is
emission of
stimulus.
the light radiation.
So any
And
instrument
this
you
light
consider,
radiation will be measured by means
three
of a
components are
suitable
very
detector.
essential: stimulus,
So
system
technique
under
is
study,
called as emission
and
spectroscopic
analytical
technique.
information.
And this, even X-ray
Same
crystallographic
presentation
analysis,
I have
ionizable
simplified here
spectroscopic analysis, or electron
from the
spectroscopic
stimulus to
analysis,
sample.
fluorescence,
Then the signal
phosphorescence, and luminescence
processor will
spectroscopic
be
analysis.
amplifying
All these type
the
of analytical
signal
techniques
coming
are
out
going to
from
be
the
employed.
detector, and the readout device will be
Absorption
giving
of
you the
radiation.
respective plot.
Absorption of radiation is
And
also
this is
due to the
true in
structural
chromatographic
conjugation
technique.
of any
Once you
one
introduce the
molecule.
sample into the injection
If a
port, at the
molecule is
end you will be
conjugated
obtaining
enough,
the chromatograms,
it will have the
and
greater
based on the
capabilities to
positioning of the
absorb the light
chromatogram,
radiation,
if mass
and the light
spectroscopy
radiation
detector
may be
you have
belonging
used,
to either UV
and
or
based on the M
visible
by Z
radiation.
value, you will be in a position to say
Due to the
what is the
conjugation,
compound present in
the
the sample.
electronic excitation takes
And if
place
you have used
after
UV
the absorption
detector,
of the light
based on
radiation,
the
and
intensity
this
or
phenomena
absorption
is
of the
measured in
beam,
UV or
you must
visible
be able to
or
say
IR
what is the
spectroscopic
amount of
technique.
the solute
Even
present.
with
So
photoacoustic
both
spectroscopy,
qualitative and quantitative
NMR and
analysis are
electron
equally
spin
possible
resonance
while using
spectroscopic
any
techniques are
instrumental
also
technique.
employed in order to measure the absorption of radiation.
So the instruments are
And
very
if you take
essential
a
in our
medium,
day-to-day life,
which is
especially
having
in
suspended
laboratories.
matter, And when you pass a
So
white light
different
radiation through the
instruments will be
suspended
working
matter,
based
this
on their
suspended
own
matter is
principles.
going to
So let us have
make
some
the light
glimpses
radiation to be
about
scattered.
different instruments such
And
as
the amount of the light
photometers,
radiation which is
atomic
going to
emission
be scattered
spectrometer,
can be
pH meter,
measured either in
potentiometer,
turbidimetry
coulometer,
or
etc.
reflectometry. And even the
So
blue
by
color of
using
the sky
photometer,
is due
spectrophotometer,
to
you need a
Raman
lamp, you
phenomena,
need a source
and that could
in
be
order to
measured in
provide
Raman
a
spectroscopy.
UV
The
radiation
water
or
droplets are going to absorb
radiation
the
belonging to visible
radiation,
region
white
of
light
wavelength
radiation, and
200
they
to
are going
400
to
nanometer
scatter
or
blue
400
light
to 800
radiation. That's why
nanometer
the sky
with
is
respect to
blue in
UV or
color.
visible region.
So this is the common
You need a
phenomena
tungsten
which we
lamp.
can see in
A
Raman
tungsten lamp
spectroscopy.
is going to be the
And
stimulus.
not only this
A,
colored
a
radiation or
light
blue
beam
color
from
of
the
the sky,
tungsten
but
lamp is
also
going
the
to
scattering of
interact
the
with the
white
analyte
light
present in the
radiation
system
can be
under
seen
study,
while
and
following
analytical
turbidimetry
information
or
will be obtained
nephelometry
as a
principles.
attenuated light
And
beam.
a very
And
simple
with respect to this
example in
light
order
beam,
to
what is
put
the
under
amount
turbidimetry
transmitted
and
out or what
nephelometry
is the amount
principles is
absorbed?
determination of
We will be
sulfate by
capable to
using barium chloride,
determine
which
the
is called
quantity of the
hydrochloric
analyte.
acid medium.
Even in
So when
atomic
you take
emission
sulfate and
spectrometric
equate with
technique,
barium
we will be
chloride,
using
barium
inductively
chloride is
coupled
going to
plasma
react
as a
with
source,
sulfate to form barium
and
sulfate, which is going to
UV
be
or
an
visible
insoluble
radiation
precipitate.
emitted out by the
Due to
atom or
the
by the
lower
molecule
particle
is going
size
to
of
be
the barium sulfate,
measured.
barium
pH
sulfate
meter
can be made to
sensor
become
such as
suspended in
pH
a medium
electrode or
of
glass
glycerol
electrode is going to
and
be
in
used
the
in order
presence
to
of
measure the
hydrochloric
hydrogen ion
acid.
activity as
So when
analytical
you pass
information.
white light
So
radiation through
pH
the
electrode is
suspended
going to be
matter,
the
the
stimulus,
light
the
radiation is going to be
potentiometer,
scattered.
cathode,
And when you
anode, or
place a
working
detector
electrode or
at an
reference
angle 90
electrodes are
degree or
going to be the
180 degree
stimulus,
with
where
respect to
the change in
light
potential of
beam,
the working electrode is going
the
to be
angle of
measured with respect
scattering,
to the
the
reference
scattered
electrode in
light radiation
potentiometry,
can be easily
and
measured.
this potential is
So
going
this
to
is
be the
seen in
analytical
turbidimetry and
information about the
nephelometry.
solution. And in
And even
coulometer,
in
we
the
will be using
same
a direct
scenario,
current
the
source in
refraction
order to
of light
measure the
radiation
quantity
can
of the
also be
charge
measured in
generated or quantity
refractometry
of
and
the charge
interferometry.
utilized in order to convert the
So
analyte
similarly,
from one
diffraction
form to
of light
another form.
radiation, what we
This
can
will be
see
done
in
in
X-ray
coulometric technique. So
diffraction
charge required to reduce
analysis
or
and
oxidize
electron
the substance
diffraction
will be
analysis,
measured as
and
analytical
even
information.
determination of circular dichroism or
So,
optical
what are the
rotatory
instrumental
dispersion, and
technique
this is
you are going
purely
to
due to the
use?
enantioselective
And if it is
property of the
involved
organic
with the
molecules.
measurement of either
If a
electrical
molecule is
properties such as
levorotatory,
potential, current, conductance, or
which has the
resistance,
capability to rotate
or
a plane
charge,
polarized
whatever it is,
light towards
they
the
belongs to electroanalytical
anti-clockwise
methods.
direction,
They
left-hand
belongs to
direction. And if
electroanalytical
a
methods. So
molecule is
these electroanalytical
dextrorotatory,
methods are
that has
nothing
the
but they
capability
are
to rotate
instrumental
the plane
methods
polarized light towards the
in which
right-hand direction or
in
clockwise
which
direction.
the electrical
So
property
all these
of the
things are
analyte is
kept under
going to be
instrumental techniques.
measured. The
Here
electrical
I have
properties may
presented
be
the first technique in
either
green color,
current or
emission of
potential or
radiation.
resistance or conductance or
Emission of
coulombs,
radiation is
charge.
presented in green color
So
because
a
when you
typical
make a
redox
molecule
process
to
is
get
required.
incidented
A
with a
chemical reaction
monochromatic
between
beam
two
of light
reagents
radiation,
must be taken place.
due to the
One
structural
reagent must
arrangement
be
of that molecule, the
reducing
molecule
agent
will
and another.
capable enough to emit a light radiation of different wavelength or different color. That's what it has been kept under green color. In order to distinguish the analytical techniques present below, out of 6 analytical methods, instrumental methods, the first one is highlighted with green color because this instrumental method means emission spectroscopic method in which the amount of the light emitted is going to be measured, and the rest of the instrumental methods are put under yellow color. Here the electromagnetic radiation is going to be changed once its interaction with the analyte is done. If you pass a electromagnetic radiation through the analyte, the nature of the electromagnetic radiation is going to be changed either in the form of absorption or scattering or refraction or diffraction or rotation. That's what all these 5 instrumental techniques are kept in yellow color. And even the electrical properties of the analyte can also be utilized. The electrical properties such as potential, charge, electrical current, and resistance. So the electrical properties such as potential of the analyte is going to be measured in potentiometry or chronopotentiometry. The electrical charge, in order to convert the analyte from one state to another state, either we have to oxidize or reduce the analyte. During doing so, or during the oxidation or reduction process, some amount or some quantity of the charge is going to be utilized or generated, that will be measured in coulometry. And even electrical current, what is the amount of the current going to be generated due to a parallel redox process, because electrons will be moving in opposite to the current. So eventually or obviously due to the chemical redox process, there will be a obvious generation of the current, and that is going to be measured in polarimetry or amperometry. And even electrical resistance or conductance will be measured in conductometric titrations, and these conductometric titrations are performed for the solutions which are having electrolytes, and this is applicable for the dilute solutions. So first four presented in this particular table are the instrumental methods, and in which the electrical property of the analyte are going to be encased in order to classify the instrumental techniques. And even the mass of the analyte can also be measured in gravimetry. Gravimetric reactions can be performed even in classical methods also. But even electrogravimetric technique can also be performed. Thermogravimetric technique can also be employed. In electrogravimetry, by using the electrical properties such as potential and the current, we will be converting the solute which is present in the solution state to variable state. So that is the principle of electrogravimetric technique. And even in thermogravimetric technique, we will heat a compound to a particular temperature in order to remove any decomposable matter, and the final product is going to be weighed by means of a microbalance, and this is seen in thermogravimetric technique. So mass of the analyte is going to be measured in gravimetric technique, either in electrogravimetry or in thermogravimetry. And if you go to the next technique, this is mass to charge ratio is going to be measured in mass spectrometric technique. When you bombard a organic molecule with a beam of high energy electron, the molecule is going to be fragmented into different forms. The molecular masses of those fragments, the molecular masses of those fragments are going to be measured by means of a suitable detector. And this process will be done due to the presence of ionization chamber, where a high energy beam of electron is going to be generated, and that generated high energetic electron is going to be bombarding the organic molecule, and dependent upon the ability of that organic molecule to get bombarded with the high energy electron, that will undergo fragmentation. And say for example, you take beta carotenoid or benzoic acid, whatever it is, either you take complex molecule or simple molecule. Simple molecule as well as complex molecule, both of them have got the equal probability to undergo fragmentation. So type of fragmented ions, the fragmented ions may be cation or anion, radical cation or radical anion, whatever it is. All these types of ions are possible in mass spectrometric technique, where we are capable enough to see the parent ion, daughter ion, molecular peak, metastable peak, all these things you will be studying in the mass spectrometric technique. So mass to charge ratio of the fragmented ion you are going to measure, you are going to utilize in mass spectrometric technique. And if you are going to perform a kinetic methods or kinetic study of the chemical reactions, you will be definitely knowledge you about the rate of the chemical reaction. So chemical thermodynamics, it is very important, and similarly kinetics of a chemical reaction is also very important, because uh, there are millions of chemical reactions we are able to perform in our laboratory. One chemical reaction may be rapid enough and the other chemical reaction may be slow enough. So for a rapid chemical reaction, it is an ultimate aim to identify what is the product going to be formed. In the meantime, if you consider a slow chemical reaction, we will not be in a position to identify the single product obtained at a definite interval of time. Say for example, you take benzoic acid, you dissolve in water. Benzoic acid is insoluble in water. If you titrate benzoic acid with aqueous sodium hydroxide in water medium, though benzoic acid is acidic and sodium hydroxide is basic, we will be expecting or we will be anticipating a neutralization process between benzoic acid and sodium hydroxide. But the reaction is very slow, very slow. The neutralization process is not going to be very rapid. Similarly, if you consider the reaction between methanol and hydrochloric acid, similarly you consider the reaction between glycerol and sodium hydroxide, whatever it is. So the slow reactions can be subjected for study of kinetics, and by means of them we can decide the reaction is either first order, second order, third order, or pseudo first order, whatever. So this will be done by simply following the principles of titrimetric analysis or even by flow injection analysis. All these reactions are kept under kinetic methods, so in which rate of a chemical reaction can be determined. And other typical class of instrumental methods is thermal methods, where the thermal characteristic of the analyte which is present in the sample is going to be encased. Say for example, in thermogravimetric method, as I told you, we will be heating the given compound to a temperature of say 100, 200, 300, 400, up to 5000 degrees Celsius. We will be heating the given compound. So the compound will undergo for different decomposition steps, and we will be in a position to study what are the decomposition products obtained after subjecting the given compound for thermal energy. So the weight of the final product at the given temperature will be measured in thermogravimetric method, where the weight will be recorded with the aid of a thermobalance. Thermobalance will be present in situ in the instrument itself. So at the different temperature intervals, we will be in a position to record what is the weight of the product obtained. Say for example, Fe2O3 2H2O. This is a simple molecule, iron oxide, Fe2O3 2H2O. It has got two water molecules. When you heat Fe2O3 2H2O to a temperature of 105 to 110 degrees Celsius, the solvent evaporation or the elimination of the water molecule is going to be taken place. So if you heat a compound to 100 degrees Celsius, 1 mole of water is going to be eliminated out, and you will be ending up with Fe2O3 1H2O at the temperature 100 to 105 degrees Celsius. If you still continue heating of that particular compound to a temperature around 200 degrees Celsius, one more mole of the water molecule is not only eliminated, but also the state of Fe2O3 is also disturbed. The state of Fe2O3 is not going to be maintained at 200 degrees Celsius, because Fe2O3 is prone to undergo FeO, iron oxide. Fe2O3 prone to undergo iron oxide at that particular temperature. So, what are the transition states of the given compound at the different temperature ranges we can easily study by subjecting the compounds to thermal analysis. So, not only thermogravimetry, thermometric titrations can also be performed, because we know chemical reactions are exothermic and endothermic. Either the liberation of the heat energy or absorption of the heat energy can be measured in exothermic or endothermic processes of chemical reactions. So what is the amount of the heat energy liberated can be measured in exothermic reaction, and what is the amount of heat energy absorbed in the endothermic reaction can be measured in titrimetric method. So simply let us assume the reaction between hydrochloric acid and sodium hydroxide. It is a better specimen example in order to depict exothermic reaction. As soon as sodium hydroxide is added to the hydrochloric acid, the temperature of the solution is going to be increased. So the incremental addition of sodium hydroxide can be made, and the incremental increase in the temperature can be measured. Similarly, if you add potassium iodide to water, it is going to be the endothermic reaction. If you dissolve potassium iodide in water, the solution will become cooler, solution will become cold. So this is a very simple example to show endothermic reaction. So what is the amount of potassium iodide added to the solution of hydrochloric acid? The heat energy is going to be released after mixing potassium iodide with hydrochloric acid. So like this, many endothermic or exothermic chemical reactions can be employed, and titrimetric technique can be encased in order to measure the temperature, and these type of titrations are called as thermometric titrations. And even differential scanning calorimetry, differential thermal analysis, thermal conductometric methods, enthalpymetric titration, direct injection enthalpymetric titrations, indirect injection enthalpymetric titrations, enthalpymetric neutralization titrations, all these things can be done under thermal methods. So in all these thermal methods, the thermal characteristics or thermal property of the solute is going to be encased. And even some compounds are radioactive compounds because of presence of the elements, a radioisotope in those particular compounds. And in these compounds, the radioactivity of the compound or the element is going to be encased. Means the radioactivity is going to be the characteristic of that particular compound or the element, and that will be obviously measured, and these techniques will be falling into activation and isotopic dilution methods. So radioactivity activation methods or isotope dilution methods are going to be employed in order to study the radioactivity of any element or radioactivity of any compound. So if you look at this particular table, and if you have a glance, the first four instrumental methods are going to encast the electrical property of the analyte which is present in the sample, and mass to charge ratio is going to be encast while following mass spectroscopic technique. And in kinetic methods we will be studying the rate of the chemical reaction, and in thermal methods we will be utilizing the thermal property of the analyte, and in radio analytical methods we will be utilizing the radioactivity of the analytical methods. So irrespective of the instrumental method, whatever the instrumental method you are going to use for the analysis, the analytical property of the analyte is very, very important. Either physical property it may be, or chemical property it may be, electrical property it may be, or thermal property it may be, whatever it is, conjugation it may be, or structural arrangement it